Okay, hi. In this video, we're going to be looking at tutorial 5, question 2. Okay, so in this question, we are basically trying to analyze how a data forwarding hardware can actually be realized. If you look at this two instructions here, uh, the data hazard that we see is the first instruction is writing to register 2, and the second instruction is actually reading from register 2. Okay. And the hazard, as we know, is this write back only happens in the last stage. Okay, and this register 2 data is actually read by the second instruction in the decode stage itself. Okay, so if we do not handle this, then the second instruction will be using the old data in register 2 instead of the updated one. And the way data forwarding works, as we have seen in the lecture, is this operation, this subtract operation, gives me the result in the exe stage itself. That means once the ALU completes this operation, the answer is actually already available for me, okay, which is in stage 3. So I can straight away use this information instead of waiting for the data to be returned back. Okay, so how it works is, if my previous instruction, okay, the data is available from the exe stage, once it is available, I can forward it to subsequent instructions that are in the pipeline and need this data. Okay, so let's see how the hardware can actually work and understand how we can actually come up with a logical way of analyzing this. Okay, so given these instructions, okay, we can see that this when the first instruction, which is a subtract instruction, so this subtract instruction comes here. Okay, subtract 2, 1, and 3, and the earlier instruction here, which is the add instruction, is in the IDEX stage here. Okay, so when this second instruction is in the decode execute stage, okay, the value that I've already read from the register 2 here, which is RS2, is the R data 1. Okay, and this value is actually, in this case, the wrong value, okay, because it is not updated yet. Okay, so if I use this and pass it to my ALU, then I'm going to get the wrong answer. Okay, so how does a data forwarding mechanism work? Okay, I check that the instruction in the EX mem stage, which means the one instruction just before mine, if the destination register number, okay, which is 2, if this is the same as the instruction in my IDEX stage, okay, the source register. So you have to remember that the EX mem stage and IDEX stage are just one clock cycle apart. Okay, so if my first instruction here is in the EX mem stage, the second instruction is in the IDEX stage. Okay, and I'm trying to check that the destination register here is the same as the source register here. Okay, if this is true, then what should I do? I should actually take the data, which is the ALU result, to be used as the input over here. Okay, that means this ALU result that is connected here, okay, should be channeled back here as the input to the ALU. Okay, so let me repeat that again. What we are trying to do here is we are trying to check for a match between the destination register of the instruction in the EX mem stage, okay, which is the first instruction, and see if it matches the source register, okay, of the instruction in the IDEX stage, which means the second instruction. So both of them are one instruction apart, and we are trying to check if the destination register from the first instruction matches the source register of the second instruction. If that is the case, then what I want is that the ALU result should be channeled back, okay, as the input to the ALU. And how do you do that? You use a multiplexer. Okay, so we will put a multiplexer in front of the RS of the first operand of the ALU. So this is the operand 1 of the ALU, and this multiplexer will then decide whether to take the data directly from the register file or to take the data that is read back uh, or which is channeled back from the ALU output. Okay, so that is basically how we can design data forwarding hardware. Okay, so this is not complete. Okay, this is just showing you just one scenario. In reality, there are a lot of multiplexers in various parts of the processor to handle a lot of different type of hazards that a pipeline processor can actually encounter. So we're just showing you one part of it. Okay, and as you can see, the logic is basically trying to analyze this relationship here. Okay, that the execute memory stage destination register is the same as the IDEX stage source register. Okay, and if this is satisfied, then the multiplexer, okay, will select the ALU output to be the source operand for the next operation. Now that we have seen this, we can look at how we can deal with different type of hazards. So if I look at these three instructions, here to here, this is exactly the same as what we saw. The destination register of operation instruction 1 is being used as a source register of instruction 2. And similarly, here to here is also the same. Okay, the destination register of instruction 2 is the same as the source register of instruction 3. Okay, now interestingly, if let's say instruction 1 is still the same, okay, so I have operation 1 register X, okay, any register and any register here, but my second instruction is written as this, okay, operation X, any register, and then X. Okay, now that I change the second instruction slightly, do you think that the earlier hardware that we just saw solved the problem? Okay, so if I look back at the earlier hardware, this is what we have. Is this hardware going to solve the problem or the challenge of data forwarding if this is my second instruction? Okay, the answer is no. Okay, why? Because now in the previous instruction, it is doing a forwarding from the uh, destination register, or okay, maybe I should put it as the ALU output. Okay, the ALU output to the RS bit location. Okay, but now what do I have? I have a forwarding from here to the RT location. Okay, that means this is actually the second operand of the ALU, not the first operand of the ALU. So if I want to solve this, I actually need to do what? I actually need another multiplexer here, where one of it is the ALU and the other is your RT, the data in your RT. And then this will go here. Okay, so as you can see, it is not so simple. There are a lot of multiplexers with a lot of control signals to handle different types of data forwarding mechanisms. Okay, so this is just to show you and give you an idea on how this kind of hardware can be designed. Okay, but a processor that supports pipelining would have all this hardware in place to handle the different type of hazards that we can encounter. Okay, so in the next video, we will be exploring how data forwarding mechanisms as well as control hazard mechanisms can change the way a sequence of instructions are going to be executed. Okay, so we will discuss more on that in the next video. Thank you.